Hey, good morning, folks. Welcome back. It is Wednesday, halfway through the week, and yeah, I got a little bit of work to do. I looked at some of those test scores, and not everyone has completed that test, the one that we issued the other day. So I'm hoping more people can get that complete because right now I only have 3 in. I should have at least 7, so that is something hopefully people can get taken care of, because like I said, these, as we get up in the levels, they don't issue that much work. So everything is definitely worth something, and it's worth a minimum 5% of an overall mark. So it's good to have those completed. What we're going to do today is we're going to talk a little bit about some welding symbols. So we talked a bit about print rating, and we're going to touch on some welding symbols quickly. I don't know if I'm going to give you any homework for today or schoolwork for today, but what I want to do is I want to go over a slideshow with you guys on some welding symbols. Some basic ones, some ones that get more advanced, but we're not going to get too advanced with it. So what I'm going to do is I'm going to share my screen, and then what we're going to do is get this happening here. So yeah, screen here, we'll share that. Now what we're gonna do is pop into our bright space, and we will minimize this, get that out of the way. So we did our print rating modern welding assignment. I just got to look at that. Did the weld symbols ILM and the objectives quiz. So we've got some weld symbol worksheets, some weld symbols PowerPoints. This one I have here is gonna be helpful for you guys. It's a fairly short one. It does say it's 30 level and advanced, but it's only advanced if you make it advanced. It can be applied to all of the levels. So we're gonna pop this out here, and we're gonna work through this with you guys and kind of talk through this just a little bit. 17 slides. It's been condensed. There's lots of good information in here, and we're going to start rolling through this. So let's see if we can open this in Google Slides and go present mode. See how this one turns out. Some of these don't format the best when we go to Google Slides. All right, so that one doesn't look too bad. So yeah, it's FAB 3050 arc welding 3, but I use it for all my levels. I just basically apply it differently and create different levels of work for it. Outcomes and objectives. Upon successful completion of the lesson with the FAB 30 or 3050, you'll be able to effectively interpret welding symbols. The objectives we have here for this are to explain the purpose of welding symbols, identify basic data included in a welding symbol, and show how a welding symbol can be used to identify or specify the location of a weld, type, welding process, root opening, contour, degree of penetration, and type of electrode. So the basic idea behind these is to create a small symbol with all the information we need to tell us how that weld should be created, its profile, its shape, its size, contour, length, and the processes used to do that. This is a lot easier than writing a small paragraph on a drawing. It keeps it much more clean and easier to read, because sometimes drawings can be quite cluttered and they become much more confusing than they need to be. So why? They provide an efficient and standardized shorthand means of conveying complete welding information on a shop drawing. So shop drawings usually have the pieces, the welds. We've got different types of drawings. We got shop drawings, we got assembly drawings, we got exploded views, we got all sorts of different things, detail drawings, and they can all be incorporated. We're going to play around with a bit of that when we get back into class. And if you guys take the 30 level, we're going to be working more with drawings and creating our own drawings at for FAB Project D. So what is a welding symbol? A welding symbol is an assembled symbol that includes weld symbols and supplementary symbols. So weld symbols just says, hey, this is what the weld is like. Supplementary is going to be all that extra information that says, hey, this is how it's done, this process, this way, this size. And basically the weld symbol is, if we're talking about cars, it's the model. The supplementary weld symbol is the spec. It's how it's finished. So basic weld symbols here, and I've got examples of these up in the class as well. So I really like to keep these around and just get familiar with them. I don't push these too hard and I don't get too in depth with them, but we do need to be familiar, especially if, say we get the ability to do things like Skills Canada post-COVID. You have to use welding drawings to complete and assemble a piece and weld it out as per their specifications. So knowing these symbols or being familiar with them is going to be helpful. So what we have here is a servicing weld. We're going to see this right here. It's got these two little bits here. And that is going to be very similar to the padded plates you guys have done with gas metal arc welding and shielded metal arc welding. This is very good practice for running stringers, getting nice amounts of overlap, but also serves a purpose. Surfacing can be used for buildup on worn parts and materials. So we consider that a type of weld. Triangle represents fillet weld, most common weld we do. And with this rectangle here represents a plug or a slot weld. And those are your standard types of welds. Here we got groove welds, and we've got different types of grooves. Square groove, not the best one, that's for sure. We got V groove preparation, bevel, U. We got flare bevel, we got flare V, and we got J. So J is half the U, bevel is half the V. We got flare bevel, which is half of the flare V. So they're just iterations and extensions of each other. So it's all pretty easy once you understand the basic concept. It's just a little extension off of the basic symbol. Supplementary weld symbols, some extra ones. Talk about welding all around. That is that circle that encompasses the arrow and the line where the reference line and the arrow line meet. That basically means just weld everything you can reach. The field weld with the black flag there, it says, hey, this is to be installed in the field. Normally things get assembled in a shop, shipped out to the field, and then put together there. That basically, that black flag tells the welder in the field that, hey, this is what you're going to weld and this is where you're going to weld it. Back or backing right here, that's going to be, sometimes we put a back or a backing on a weld just to stop us from burning through, to make sure we get complete penetration into the base metal, things like that. Melt through, that is going to be like our groove welds that we've been doing. So on our groove welds, we want melt through and we want that reinforcement on the back. That is a good route. Otherwise, you don't have full penetration of the joints. Contour symbols, flush. So top's gonna be flat with the plane of the steel you're welding on. The groove weld is gonna be a pretty much completely flat weld. Convex is gonna have that bit of humpiness to it, and concave is gonna have that little valley in the middle there. So this is a reference line with an arrow. And we're going to start talking about these parts and pieces. We got an arrow line, got a reference line, got the tail back here, specification, process, or other reference. So they'll put information back there. It might say C note J2, and you look on the corner of the drawing, and note J2 will give you some specific detail as to how to complete that weld. Basic weld symbol, detail, or reference. It's going to be on either side of the line. Other side is top side. It doesn't always work that way. Other side can switch. It depends on where the arrow points. And the underside is going to be the arrow side. So if that arrow was pointing up instead of on a downward angle, the arrow side and other side would alternate. The way I use this is I look at which of these here. So if I was drawing that field weld symbol, I do that circle here, the smaller of the two circle pieces. So this would be a bigger one encompassing what? I don't know, 200 plus degrees, and this would be a smaller one, say 160 degrees, right? The smaller one is always going to be the arrow side. So that's how I remember that. So we got some weld symbols here. So we got fillet weld other side, bevel preparation on the arrow side. We have weld all around and weld all around in the field. That's a field weld. So you can combine and stack some of these welding symbols. Here, it's going to give you a size of a weld, and E is for effective throat. That's how much penetration we get into the weld and how big our weld is overall. L and P is going to be length and pitch if we're doing intermittent welds or chain intermittent welds. It's going to be length of weld and the pitch center to center of the welds. It's not, say, let's use 5 and 10, 5 for length, 10 for pitch. It's not going to be 10 centimeters between your welds. It's going to be 10 centimeters from the middle of your weld to the middle of your weld. So it's only going to be 5 centimeters actually between your two welds. A lot of people get that confused. So what we have here is a bevel preparation. I'm just going to talk about root opening, and that's going to generally give you a measurement in there, and that'll say depth of filling for plug and slot. A is going to be a groove angle. For us, I cut all of these, so we don't really worry. But if you're preparing your own steel, that is going to be important, because if it's a hot process, you don't want really thin walls. You want steeper walls, so you have more material to grab onto. You got less chance of burning through. It's going to be a finish symbol. It's a flat contour. Oh, finish symbol is the top one. Sorry, the last one's the contour symbol. Finish symbol is going to tell you how we are going to finish out that weld. Sometimes we're asked to do things that seem contradictory, like chipping or peening. That's going to basically beat up the weld, but it has a purpose. It'll be probably stress relief is the big one on there. But I don't beat up welds unless I have to. I try and keep them looking pretty. So location of welds. I'm going to flip through this real quick. We got the arrow side is going to be the smaller side, as we can see here again. If we were to draw a circle here, this would be the smaller part of the circle. So that's going to be the arrow side. Arrow side is just going to say, hey, putting that fillet weld right here. And we can see on the right that that's where that is. If it's going to be on the other side, it's going to be the same thing, but on the opposite side of the weld joint. So even though the arrow points here, it says the other side, it's talking about this joint, and then the weld will be placed on the opposite side. So location welds on there, obviously, if we know what the first and the second one are, this would be quite simple. It's just gonna be welding on both sides. So this is where it gets a little trickier. We're talking about square butt joints now. So this is other side. So on the top side, the weld is going to be prepared like that. And both sides preparation is going to be just like that. So fairly simple. As a new concept, it can be hard to understand, but once we start building a little bit of familiarity with it, it is going to be quite nice and easy to learn. So we got a few more things here. Types of welds. So the top one, we would have actually, what do you guys think? Top left. Feel free to shout it out, doesn't matter.
Oh, okay. Gotcha. Okay, perfect. All right. All right.
No takers. All right. So that one's going to be a fillet weld on the other side.
Because I need to be able to show. I never got that.
So the next one here is going to be other side, and it's going to be a square butt weld. Bottom right-hand corner is going to be arrow side, and it's going to be a plug or a slot weld. And the next one is going to be arrow side, and it's going to be a surfacing weld. So we got a few of those, a couple more pictures. Just going to continue this exercise a little bit. So here we got arrow side V groove. The next one on the right on the top is going to be an other side bevel. Bottom left here, we have an other side J groove preparation. And the next one we have here is going to be an other side U groove preparation. So fairly simple. Try not to go too crazy. So But here we have some root openings, bevel angles. So here is going to be root opening, depth or filling or plug or slot. Do here, guys, I'm just going to plug in a mic just to make sure that we get everything here. All right. So we've got this one here. And then what we have is groove angle, countersink for plug welds. So it looks something like that. That would be root opening and depth of filling, plug or slot, which would be 3, and then the groove angle would be 30. So each plate would be beveled at 30 degrees to complete the included angle of 60 degrees. So the last one would actually look something like that. You have a 3 millimeter root opening, 60-degree included angle. So that's what it would look like. That would be the completed weld. So depth penetration is basically something you don't often see that on weld drawings. I've never really seen it, but they have certain expectations that you do get full penetration of the weld. But I don't actually see them measure the penetration of your weld, because to do that would have to be a destructive process. They'd have to somehow get in there and check it out or x-ray it. And if it's very important, they will x-ray it. But honestly, it's a lot of time and money, and a lot of trust is placed in you as a welder to complete the job as per spec. So depth of penetration there is the throat. And then what they'll ask is the preparation depth there. So you'll see usually the preparation depth is going to be a little smaller than the effective throat. They'll say, hey, 8 mil preparation depth and 10 mil effective throat of the weld. So that means they want a couple millimeters of preparation. So there's a little drawing that overlays that, and hopefully that helps you out in understanding that. And yeah, so here we have the size. That could be an 8, effective throat could be a 10. That's how that would be shown. So this one, if we're drawing a weld symbol, it would be pretty simple. We would have a 6, then a 9 in brackets. So yeah, that's that one there. Contours, 3 different contours we work with: flat or flush, convex, and concave. We talked about those a little bit. Finishing symbols, got a bunch of them. M is for machine, C is for chip, G is for grind, H is for hammering, R is for rolling. I've never seen a rolled weld. U is for unspecified. If it says unspecified, I just leave it as is. But honestly, I don't see many welds ever with a specific symbol on it. If you work for some companies that do some pretty important jobs, say aerospace, stuff like that, they will have specs like that. But generally for your first few welding jobs, you're not going to be getting into anything too crazy. And then where you decide to go from there is up to you, because welding can create a lot of opportunities. It can open a lot of doors. I've had opportunities to work in mines and oil and gas. I've even had offers for aerospace stuff, power transmission stuff. I've been able to have the ability to open up windmills down south. I turned that down just because I didn't want to be away from home during that time. But yeah, really welding can open up a lot of doors and take a lot of places. But yeah, it's really up to you guys. So contour and finishing. We got a fillet weld, we got a plug and slot and a V groove here. So on the fillet weld, we have a flat finish. The plug and slot is going to be a convex finish, and the V groove is going to be concave. And those can be made those ways. So the flat is going to be made by machining. The convex is made by chipping. That's kind of weird. And the concave is by grinding. So fillet, flat, machine, got that one. Plug or slot, convex, and chip, we got that one. The groove is concave by grinding. That one's probably one of the more realistic ones. Type of electrode, you're gonna find that in the tail. So that's gonna tell you, it's gonna have a little spec. It'll say, hey, see this, and it could be something like a J2 or an A1, and then you'll find that on the supplementary information sheet, and that's gonna give you that. So basically it's like a little key for all the symbols on the weld drawing. You could also say something straight up like shielded metal arc welding. So that is that for this slideshow today, guys. Nice and quick. Try and plow through these. I don't want to waste too much time. That's open and it's up for your reference there. And we're going to start working off this in the next couple of days here. So I'm going to have a couple exercises where we'll read some weld symbols, we'll draw some weld symbols, and this PowerPoint here is going to be the key. That's going to be what you're working off of, and that's what'll help you with this job or those tasks. So quick, just a quick review on the print rating. I don't want to get too deep into it. I'm really hoping this 2 weeks doesn't become 4 or 6 or the rest of the year. I'm staying hopeful and optimistic as more people are getting vaccinated. Chances of this being extended are going down, and I want to stay that way. But I really want you guys in here in 2 weeks because we have a lot of cool stuff to do in the next little bit. Arc 1 and Arc 2, probably one of my favorite units. Arc welding is my bread and butter. It's what I learned on. That's why I stayed employed on so many jobs. A lot of guys become shop guys and they love to burn wire in a nice shop where it's, fairly clean, but it's protected from the elements. I always love being outside. As you guys know, I do a lot of backpacking. So Elisa asks, the weld will only be classified as arrow side if the weld is on the side where the arrow is pointing. Yes, generally. So if we have a flat reference line, the arrow is pointing down at an angle. If we look at that joint between the reference line and the arrow line, the smaller side, there's going to be a smaller side and a bigger side, right? So if we're talking 360 degrees, we're going to have 200 degrees plus on one side and 160 on the other. The smaller of those two is always the arrow side. So if the arrow is pointing up, the smaller side is going to be on the top, or the smaller angle or piece of pie is going to be on the top. That's going to be the arrow side. So the arrow side can flip, but usually it's the arrow side is always the side closest to the arrow. Is if that makes any more sense that way. So that's how that one works. But shielded metal arc welding 1 and 2 are going to be fantastic. I love those units. We're going to play around with a couple different types of rods. We're going to use some stuff like 7024. That's a great big rod, ton of iron in the flux, and the supplementary that actually becomes part of the weld. So if you break the flux off that rod, you can pick it up with a magnet. I do that in class to show you guys that. Since it's got such a high iron content, that rod is only used in flat and horizontal positions. If you start taking that out of position into vertical or overhead, it's going to be a mess and not a fun time. So it'll be neat. We'll play around with a whole bunch of different types of rods, get you used to some different things, some 6010, some fast freeze, fast fill rods, some general stuff, 6813, 7014. There's a lot of cool stuff. I've got some Unichrome at my house I might bring in, and it's a little bit of a pricey rod, but it is used for joining dissimilar things. So you could join stainless steel to regular steel. You can weld stainless steel with it. It's pretty neat stuff. So I'm going to bring that in once we get back in, play around with a lot of that stuff, and then we'll practice some welds and some weld joints. And so that is it for today, guys. That is all I am showing you. I want to rip through that quick. I think I may have touched on that in class, but it's nice to rip through it again. This is recorded, so you will have it as reference as well. So tomorrow we're going to meet up. I'm probably going to issue a new link for Friday, or I'll just say meet at a regular time on Friday, even though our link says 9 o'clock here. We'll meet at, 9:30 on Fridays? Yeah, 9:30. So we'll meet on our regular time on Friday, but what we'll do is we'll just use the existing link we have. That will work. Just click on that link and I'll make sure it's open at that time. And we'll just run a real short class on Friday. But this way I'm not issuing a second Zoom link, creating a bunch of work for you guys, confusing everyone, and creating a bunch of work for myself. Yeah, so that is all, folks. I'm gonna stop this recording now.